Today we will solve together MCQ questions like the type you will have in the exam. And if you have any questions for the exam after we finish them, also I will answer your questions. This is typical style of questions that you might encounter in the exam. So always when you have multiple choice question, read all the possible answers because you can have several possibilities. Okay, so sometimes 1, 2, 3, 4 correct answers. So read all the possibilities and select the correct ones. In the first question, which of the following industries are classified as secondary industries? So here, to be able to answer such questions, we should know what is the definition of secondary industry. So secondary industries will take the primary products of primary industries and convert them into useful products. So in this way, we have manufacturing processes that will be used to transform from initial state to final product. So, for example, beverages is one of the secondary industries because we mix several primary products in order to get a final beverage. Okay, so this is a type of secondary industry. Financial services is which type? It's a service. It is in the service sector. Because it is in the service sector, so it is a tertiary industry. So it's not included in the secondary industry type. Fishing is primary industry because we are just taking products in their natural way. Mining also is primary because we do not alter now the product in this state. We should take them to other secondary industry to change their state. You have power utilities will give us equipment that can be used in our life, so it's a secondary industry. Publishing is a secondary industry because it will end up with books. We can convert primary uh, uh, objects to final products as textbooks, as journals, so it is a secondary industry. And transportation is a service sector, so it's tertiary industry. Now, for the second question, which of the following engineering materials is defined as a compound containing metallic and non-metallic elements? So, of course, whenever we define in the course ceramics, metals, polymers, we should know the definition of each type. And from here, the definition of ceramic is that it is a compound containing metallic and non-metallic elements. So we will select the right answer, which is ceramic. Which of the following processes start with a material that is in a fluid or semi-fluid state and solidifies the material in a cavity? We have two. Here I told you how many answers, but in the exam, I will not tell you how many answers are right. So you should read all answers and select the right ones. Okay? So here, we didn't see yet what is the difference between casting and molding, but both will consist on solidification of the material. Okay, so we will see after in detail because chapter 8 is a continuation of chapter 7. So we will see that the main difference between casting and molding is that in general we have molding is for the case of plastics, while casting is for metals. Okay, but the concept both are use the concept of solidification of the material in a cavity. So the answer is casting and molding. All other processes are not solidification processes. So you can, if you remember the categories of processes, you will know how to put each one. Okay. So for example, forging is a deformation process. Let's say you have turning is you have removal processes. So you have different processes here, but the solidification one are casting and molding. So always when in the course material we define categories, you should know for each category what is the type of processes involved. Now, for example, this is also a question in the same style. So deformation processes includes which of the following? It's not casting, of course, it's a solidification process. It's not drilling, which is a removal process. You have extrusion, yes. It's a deformation process. And also forging, it's a deformation process. The other one also are not in this section. Now, in question 5, in the periodic table, the elements can be divided into which of the following categories? We have seen together that in the periodic table, we arrange the elements in 3 sections mainly: metals, semi-metals, and non-metals. Okay, so we don't arrange them in as liquids and solids, of course not. So and not in polymers and ceramics. So we divide them into these 3 types. So these are the 3 correct answers. Karim, no, we don't have fill in the blank. You will have multiple choice questions and you will have problems. We have, I think, if I remember well, 2 problems on chapter 2, 2 problems on chapter 3, and 2 problems on chapter 6. Okay? You have in total 36 questions and 55 minutes.
دكتور gases ما فينا نعتبرهم بالبريودك table؟
لا، لأنه هي الفكرة إنه أنت each element can be in several phases حسب ال temperature. يعني if you change the temperature you will change the phase. ما خص ال division تبع التيبل بالgases والliquids والsolids. لأنه one element depending on the temperature can be in different states. Okay?
Okay, thank you.
Doctor, I was asking if in chapter 6 we should only know how to read the
Vernier
measure.
scale. How to read Vernier scales. We did together a session on this, and I posted the document in the assignment folder.
Yes.
Okay, so you should know how to read linear Vernier scales and rotary Vernier scales.
Okay.
Okay. Now, how many atoms are there in the face-centered cubic unit cell, FCC? So from the definition of FCC, we know that we have a cube, we will have 8 atoms at corners. And from the name, it's face-centered, so at the center of each face, we have an atom. So in total, we have 8 atoms at corners. And 6 atoms at center of faces. So in total, we will have 14 atoms. Okay, so here's the correct answer is E. Another question.
Doctor, is بدك the whole number of atoms بتقولي لنا انت انه full atoms؟
Yes, هون full atoms. مش إنه we take يعني we don't divide because you know that atoms are shared by several units. بس هن قصدهم هون يعني what is the number of full atoms بالunit cell. يعني إذا برسم الunit cell, how many atoms I have? This is what they mean here. Okay.
دكتور مش عندنا فور اتومز؟
ولكن بلا بس هيدي إذا عم تحكي أنت إنه you are considering that the atoms are shared with other and you divide يعني على الكورنر بتعمل 1/8. But here what we are doing here مش عم منعد إذا بدك we are considering just if I draw the structure how many atom I should draw on it. هيدا السؤال بهالمعنى. Okay. Yes, it's true إنه these atoms are shared with other يعني مش كلهم لإله بس نحن عم نعد الاتومز على الرسمة بس. This is the question. Okay. Now, let me check if you have questions until here. Yes, we have random questions. We don't have MCQ first, problems after. No. The order is random. يعني each student will have a different question, and you are not allowed to go back. So please Yani here the problems are very simple, or you know to do them or not. So you don't have to go back. You do, whenever you read a question, you do your best. For problems, you write everything on your draft, and your answer on Blackboard should be consistent with your draft, because if I have disagreement between the two, it's a 0. Okay, I don't accept the true answer on Blackboard and the wrong answer on the draft, or the opposite. Sometimes you put a wrong answer on Blackboard, then you correct it on the draft. It's not acceptable. Please, I should have an agreement between the two. Okay, and draft, yes, draft is only for solving problems. No need to justify MCQ. 6 problems, I think. I will update you, but I remember that I considered 6 problems. 2 from chapter 2, 2 from chapter 3, 2 from chapter 6. Okay.
Doctor, where do we send you the draft?
You sent me the draft directly by WhatsApp after the exam. So once I tell you I will monitor the exam on LAU WebEx. So I will send you the link. I will post the link for you on Blackboard. We will be together on a live session. You will open your cameras. Your face and your hands should be clearly shown. At the end of the exam, when I tell you to stop, you stop. You take photos. I don't want you to scan, because a lot of times they tell me the scanning application is loading and it's not working. No need to scan. Take photos and send by WhatsApp. So I will not accept late drafts. Please, once the exam is done, within 1 minute, 2 minutes maximum, I want all drafts to be received. Okay? So make sure you take photos of all your problems you did. Don't tell me after 1 hour I forgot to send this problem. Okay, so please avoid this, because these problems always happen, and it's not a good index. It will show maybe that you are cheating. So please, just when you finish your exam, you take photos of the problems, of all the problems. So double check and send them directly to me by WhatsApp. No email and no scanning application. I don't want all of these. Just, and this is the fastest way. You can directly take photos and send. And you send it by private message on WhatsApp. And also your ID should be with you. You take the photo of your IDs on the first paper of your draft. And at the end, after you send me everything, you write your name so that I can track your copy when I am correct. Okay? As simple as that.
Okay, dear doctor.
Okay. Now, let us continue. In question 7, which of the following are not point defects in a crystal lattice structure? So we have seen together what are the types. We have divided defects into line defects, point defects, and surface defects. So here we want to select the defects that are not point defects. Okay, so please read well the question. They don't ask you for point defects, they ask you for defects that are not point defects, so or surface or linear defect. So first, we know that edge dislocation is a linear defect, so I will select it. Grain boundaries is which type of defect? Who remember?
Surface.
Surface, so also I will select it. Interstitiality is a point defect, so I will not select it. Scotty defect is the Frankel defect. It's a point defect. Also, I will not select it. Screw dislocation is linear defect, so I will select it. And vacancy is a point defect, so I will not select it. So I have 3 answers here. Question 8. Polymers are characterized by which type of bonding? If you remember, in one of the chapters, we have given the characteristics of each type of materials. What are the characteristics of metals? What are the characteristics of polymers? You should know this, okay? So for polymers tend to form which type of bondings? Who remember?
Covalent.
Yes, covalent, and also hydrogen bonding, because they contain hydrogen element with other highly electronegative elements. Okay, so this is question 8. For question 9.
دكتور ما بيعملوا السكندري بونز فاندر والز؟
هن أكتر شيء بيعملوا هول التو تايمز. أوكي. يعني الدوميننت عندهم هن الكوفالنت والهيدروجين.
Okay.
Doctor,
Yes.
I have a question بس على characteristics تبع polymers.
Yes.
إذا one of the characteristics of the polymers is low thermal conductivity, إذا أجانا option electrical insulator, is it the same meaning ولا لا؟
look لا، لأن الكوندكتيفيتي لها علاقة بالهيت ترانسفير، خاصة
أوكي.
بالإلكتريك بيهيفير، هول غير بعضهم. أوكي. يعني
أوكي.
أنت مسؤول عن البروبرتيز اللي مذكورين بالسلايدز. So the properties mentioned in the slides هن ال properties of polymers. أوكي. ما خص الكوندكتيفيتي بالإلكتريكال بيهيفير، conductivity لها علاقة بالهيت ترانسفير. Okay. Now. Question 9. Which one of the following is the correct definition of ultimate tensile strength as derived from the results of a tensile test on a metal specimen? You know first that ultimate tensile strength is an engineering value, okay, and it corresponds to the maximum stress, to the maximum engineering stress. So first, is it the stress encountered when the stress strain curve transforms from elastic to plastic? Of course, no. This is the definition of yield stress. It is the maximum load divided by the final area of the specimen. Also know why? Because this is the true stress value, while the tensile strength is given from what? From the engineering value. So also it's wrong. So the maximum load divided by the original area, this is the right answer. Okay. Because by definition, the tensile strength is the engineering maximum stress. So it is the maximum load divided by the original area of the specimen. And finally, it is the stress observed when the specimen fails. Of course not. This is the rupture stress. Now, in case if you want, if I don't have necking, but this is not in case of tensile test, in compression test. In compression test, I don't have necking, so the maximum, the ultimate tensile strength will be the one at a failure, okay? But in case of tensile test, it's not the case. Here, always read well your question. It's in a tensile test. Question 10. Which of the following types of stress-strain relationships best describes the behavior of brittle material such as ceramics and thermosetting plastic? Elastic and perfectly plastic, elastic and strain hardening, or perfectly elastic? And finally, none of the above. So here to be able to answer, okay, to be able to answer, we should try to find, to remember what is the definition of these behaviors. What is elastic and perfectly plastic? So if I draw it in a log-log plot, if I do the log-log plot, okay, I have first an elastic region, and once I reach yield, I will have I can freely strain my specimen. It will undergo strain without the need to increase my stress. This is perfectly plastic. And perfectly plastic is normally the behavior of what? In which case? Yes, it's N equal 0, K equal Y. It's the case of when you heat above the recrystallization temperature. When you heat a metal above its recrystallization temperature, it will behave in a perfectly plastic way. Now, this is, so A is elastic and perfectly plastic. It's not, of course, for brittle materials. Elastic and strain hardening is, in general, the behavior in which case? Yes, it is, no, it is the behavior of metals, but not when heated at room temperature. Yes, it's the behavior of ductile materials. So at normal temperature, because if you heat, once you reach, you can heat, but as long as you are below the recrystallization temperature, you will have the behavior of elastic and strain hardening. So you will have, after yield point, you will have a lower slope. So this is and this is the strain hardening zone. So this is the characteristics of metals, for example, that are operated at room temperature, or even at any temperature below their recrystallization temperature. Now, what is perfectly elastic? Perfectly elastic is in general characteristics of what? This is the characteristic of brittle materials, because brittle materials will not undergo, cannot yield, they will not go to plastic deformation. So when I have perfectly elastic, I just limit myself to this zone, and I will not reach the yield. The rupture will take place before yield. So this is perfectly plastic. And sorry, perfectly elastic. So perfectly elastic is representing the behavior of brittle materials. Okay. For ductile, yes. For ductile, if they ask you what is the behavior of ductile material below recrystallization or at room temperature, yes, it is strain hardened. Okay. Once they tell you it is heated above recrystallization, this is perfectly plastic. Now, concerning question 11, thermal energy is normally associated with which of the following changes in the altered layer? We have, if you remember, we have seen that we can create changes in the subsurface layer by mechanical energy, by thermal energy, by chemical energy. So first, using thermal energy, cracks is not a characteristics, if you want, of the sublayer deformation. Okay, it's characteristics of surface deformation. So this is not a good answer. Hardness variation, of course, because the thermal energy will affect the hardness of the sublayer. So this is one answer. Heat affected zone also, because we said that when we have, for example, welding, or when we have cutting tools at very high temperature, the thermal energy will lead to alteration of properties of the altered layer, which will be named the heat affected zone. We have plastic deformation is not from thermal energy, is due to mechanical energy. And the recrystallization, yes, it is a process that will alter the sublayer properties, and it's a thermal energy type. So these are the three correct answers. Part 12, in casting, a flask is which of the following? It's the beverage bottle for foundryman, it's the box which holds the cup and drag, or is the container for holding liquid metal, or is the metal which extrudes between the mold hands. So here you should know the definition of all parts of your casting process. So from definition of flask, the flask is the box that contains the cup and drag. So this is the right definition of a flask. Now, concerning question 13, in foundry work, a runner is which of the following? Is it the channel in the mold leading from the down sprue to the main mold cavity? Is it the foundryman who moves the molten metal to the mold? Or it is the vertical channel into which molten metal is poured into the mold? So first, if you remember the runner, if you go back to the figure or presentation of the casting process, you are pouring, this is the pouring cup, you are pouring the metal. Your metal will go first through a vertical channel. This is called the down sprue. And after the down sprue, you have a channel that is called the runner. The runner will take your metal from the down sprue towards the main cavity. So the definition of runner is the following. It is the channel. It is the channel in the mold leading from the down sprue to the main mold cavity. So this is the true answer. Okay, the vertical channel is not the runner, is the down sprue. Now, for question 14, the total solidification time is defined as which of the following? Is it the time between pouring and complete solidification? Or is it the time between pouring and cooling to room temperature? Or it is the time between solidification and cooling to room temperature? or finally the time to give up the heat of fusion. So if you remember the solidification curve for a pure metal, we have seen that first we have a constant temperature, which is the pouring temperature. Once we finish pouring, we have the phase of first liquid cooling. Then once we reach the solidification temperature, we have a change of phase from 100% liquid at this point to 100% solid at this point. And in total, we define the total solidification time as the time just after the pouring until complete solidification of my material. So here the true answer is the time between pouring and cooling to room. It is time between solidification. This one, it is the first answer. Time between pouring and complete solidification. Okay, so this will be the definition based on this graph. So from pouring and to complete solidification. This is the total solidification. So as you can see, this is the type of details you should know. So you should read several times the slides so you can memorize this information. And for the problems, it is very similar to what we did together in practice. Okay?
Doctor,
Yeah.
I asked you yesterday if you could send us an exercise like the last one in the
Yes, I will.
problem set. Okay, thank you.
Okay.
Doctor, I have a question.
Yes.
Can you explain شو بيعمل الرايزر؟
Yes, of course. The riser, look, when you pour your metal, okay, into the main cavity, the pouring process will take place at the beginning, and then you will stop adding metal. So the poured metal will go into the main cavity, and it will start to solidify. When you have solidification, you will have shrinkage. This means reduction of volume. Okay, and since you don't want to have a lot of deviation between the form of the final desired shape and the cavity, okay, you want the riser, the purpose of the riser will be to continue to supply molten metal during the solidification process. First, this will allow to reduce the shrinkage effect. So this will minimize shrinkage. What I mean by shrinkage is the reduction in dimension when I go from the liquid to the solid state. Okay, so in this way you will reduce the variation between the cavity size and the final product. Okay, so this is the first purpose. The second purpose, when you pour your metal or your materials, your molten metal, what will happen is that you will introduce some gases will be introduced into your cavity, and if you don't remove them, this will lead to formation of voids inside your final product. So this can be avoided by the presence of the riser, because after the pouring operation is done, the riser can supply the required amount of molten metal in order to take the place of gases and escape them outside. Okay, so in this way, the riser will avoid the formation of voids and will lead to a reduction of shrinkage effect. Okay, and we will see together after in the second part of chapter 7 that will be covered after exam 1 that the riser should be designed in a way to solidify at the end of the process, because if it solidify before the main cavity, it will not be able to supply any more molten metal. So the last part to solidify in your system is the metal in the riser, because it should continue to provide the molten metal until nearly the whole cavity will reach complete solidification. Okay, is it clear?
Yes, doctor, thank you.
Okay. Any other question?
Doctor, I have a question on a problem. Can I send it to you on WhatsApp?
Yes, of
Check it.
Yes, sure.
Okay.
Other questions?
Doctor, I have a question.
Yes.
Doctor, when we want to convert from engineering stress strain to true stress strain in a compression test, we put
Yes.
the minus sign in the equation that when we convert, we put the minus sign in
Look,
for the.
if you put the minus sign for the engineering stress, you will always have a negative sign for yani what you should know at the end is that both are negative. Okay, that's it. Yani, and if you want to relate their absolute values, okay, you just put yani the relation that is valid for absolute values is the same as the one for tensile test.
When I want to use the formulas that converts from
But
engineering
of
to
course,
true,
look, yani for example, you know that what is sigma true function of sigma engineering? What is the relation?
sigma engineering times 1 plus epsilon.
Okay, sigma engineering times 1 plus epsilon. You can do a small analysis to know what to do. So here, you know that in case of tensile test, okay, in case of tensile test, sigma true is higher than sigma engineering, okay? And if I consider now, if I'm talking about absolute value. However, in compression tests, it is the opposite. Sigma true is smaller than sigma engineering. So now here, when you want to use this formula, you should pay attention. You should, if I consider that I will take the absolute value of sigma true in compression and the absolute value of sigma engineering, okay, I should pay attention that here epsilon engineering, I should take it as negative. Why? Because sigma true in compression is an absolute value is smaller than sigma engineering, okay? So in this, when you want to replace in this relation, sigma engineering should be negative, okay? But here, or you can put minus for both, okay, or you can take the absolute value for both.
Yes, doctor.
Okay, is it clear?
Yes, thank you.
Okay. Other questions?
Doctor,
Yes.
you said the number of atoms for the FCC is 14. How many atoms are for the HCP and BCC, please?
Okay. Let us go, if you want to go to the figure, okay, I will, when you see it on a figure, it will be clearer, okay? So first, what is the definition? Let me see it here. Did we represent the figure for you in the course material or not? Or it was just a description in the
Yes,
course?
Dr. في slide مبينة.
يلا
Yes.
خلينا نفتحها so you can see it directly. It is, I think, it was in chapter 2 or 1? 1, I think. So let's
Two.
2?
Yes.
2, okay, yeah. So let us see where it is. Okay. Look. So here, which one? If you want figure, yes, it is here. Okay. So first, this is the body-centered cubic. And sometimes just from the name, you can imagine the figure. For the body-centered cubic, you have 8 atoms at corners, okay? And 1 atom at the center. So in total, you will have 9 atoms per unit cell, okay? While for the face-centered case, you have, as we have seen together, 8 atoms at corners and 6 at faces, resulting in 14 atoms. Now, the most complex one is the HCP configuration. But as you can see, it's defined in a repetitive pattern where you have, for the upper faces, hexagonal faces, you have for each one 7 atoms, because you have 6 at corners, 1 at center. So you have 7 up on the upper face and 7 on the lower face, which is 14. And you add to them the 3 atoms in the middle plane, okay? So you end up with 7 plus 7 plus 3, 17 atoms. Okay? No, you should not know their coordination number. No, no need.
Doctor, you said
Yes.
that the riser reduces the shrinkage, right? I
Yes.
just want to make sure that I
Yes,
listened correctly.
reduce the shrinkage and avoid formation of voids inside
thank
the final product.
Okay, thank
Other questions? Yes, of course, I give you the units in the main scale. If I give you a figure and I want to, I want you to give me the measurement, it will be clear what is the unit of the main scale. And please always read well the question. In the question, I tell you, give me the final length in this unit. So don't give another unit. So if I tell you give it in millimeter, don't give it in centimeter. Pay attention for the unit. I will specify what unit I want. Other questions?
Doctor, are you going to solve the second set of MCQs?
The second set of MCQs, the majority of questions is not included. This is why I didn't solve it. It is for exam 2.
Oh, okay.
Okay. You can just solve maybe the first 2-3 questions because it's related to chapter 7 already covered, but they are very simple. The remaining one are not included in the exam. Any other concern or question?
Doctor, I sent you the problem. After class, I'll ask you, okay?
Yes,
Or
sure,
not?
sure. Anyway, if you have any question, you can send me it by WhatsApp whenever you want, okay? Yes, you can have the formula sheet in front of you, of course. You can use the formula sheet I gave you. Anyway, you can use what you want at the end. But look, I advise you to study well because you don't have time to go back to the course material to check answers. Okay? So time is just enough to answer the questions. This is why you should be well prepared to be able to finish your exam. Okay, guys.
دكتور كل ال MCQs راح يكونوا انه multiple answers ولا في منهم راح يكونوا بس one answer؟
في منهم
يعني
1
كله راح
في منهم 1 في منهم 2 في منهم 3 في منهم 4 يمكن يعني ما always read all possibilities, okay? You will not know if it is one or multiple answer. You should read all to detect what is the true answers.
Okay, thank you.
Okay, well.
يا دكتور ما رح تقولي لنا إذا one answer أو أكثر؟
No. sometimes the question يعني في questions أكيد يعني بيبينوا إنه one لحالهم وفي questions معقول يكونوا several answers. يعني this is why أنت always read all possibilities and you will select the correct ones. وبليز انتبهوا كمان في penalty يعني مش ما تحطوا حيلا answer if you are not sure. البنالتي مش كبيرة بس إنه this is to make sure that you do not select random answers.
يعني دكتور
نعم يا ماما. يلا يا عامر.